All right, let's talk about two of the biggest ideas in coding, procedural and object-oriented programming. You can think of them as two completely different philosophies for how you tell a computer what to do.
To really get our heads around this, let's start with something we've all done. Have you ever built something with Legos? I mean, of course you have. So picture this. You're about to build some huge, complex model. You've basically got two ways you can approach it. So on one side, you could have this massive instruction book that tells you exactly which piece to snap on where, one step at a time, in a super specific order. That's one way. But on the other side, you could start by designing your own custom parts, like a pre-built wheel assembly or a whole cockpit module that you can then just use over and over again whenever you need one. And that choice right there, between following a really strict list of instructions versus building your own modular, reusable components, that is the exact same fundamental choice that programmers make every single day. Okay, let's dive into this. So first up, let's talk about that follow the instructions method. This is what we call procedural programming. And honestly, the best way to think about it is like you're just following a recipe to bake a cake.
So what this really means is that procedural programming is a totally linear, top-down approach. Your code is just a sequence of instructions, or procedures. It literally starts at line 1 and just goes step by step by step until it hits the very end.
Just like our recipe, right? You start by getting your ingredients. That's your data in the programming world. Then you do a series of actions, or functions, on that data. You mix this, you add that, you bake it for 30 minutes. The really key thing to get here is that the ingredients, the data, and the actions, the functions, are treated as two totally separate things.
Now that works perfectly for a simple little cake. But what happens when you're not just baking one cake? What if you're trying to run a massive industrial bakery?
Yeah, what happens when that simple, one-page recipe of yours suddenly turns into a 1,000-page cookbook? With all these cross-references and variations and steps that are shared between different recipes, well, things can get really messy really fast.
And this is where procedural programming really starts to show its cracks. See, if you need to change how you mix eggs, you might have to find and update that one step in hundreds of different recipes. Code gets copied and pasted everywhere, which makes just doing maintenance an absolute nightmare. The whole thing can become this tangled web of instructions that's hard to follow, and honestly, it doesn't really work like things in the real world work. So to solve all this complexity, a totally new idea came along. Object-oriented programming, or OOP for short. And if procedural programming is like a single recipe, well, OOP is like running an entire, fully staffed restaurant. OOP basically flips the whole script. Instead of keeping your data and your functions separate, it bundles them together into these little self-contained units that we call objects. So an object holds both its own data and it holds the instructions for what it can do with that data. Back in our restaurant, think of a chef as an object. The chef knows its own ingredients, that's its data, and it knows its cooking methods. Bundling that skill and data together, that's encapsulation. Now, you, the customer, you just order from a menu. You don't need to know about the chaos in the kitchen. That's abstraction. Then, maybe you have a pastry chef who knows all the basics the main chef does, but also adds dessert skills. That's inheritance, and it's amazing for reusing code. And finally, if you tell both chefs to prepare a dish, one makes a steak and the other makes a cake. The same command gets different results. That, my friends, is polymorphism, and it makes the whole system incredibly flexible. All right, so we have the step-by-step recipe on one side and the organized restaurant on the other. Let's put them head-to-head and see how they really stack up. You can really see the huge shift in thinking here. Procedural code is all about the actions, the verbs, but OOP, it's all about the things, the nouns, the objects. And because OOP bundles data inside those objects, it's just so much easier to reuse and to scale up. But the biggest thing, the crucial difference, is that it just maps way more intuitively to real-world problems. You can have a car object or a customer object, which just makes so much more sense when you're building complex systems. Now, let's be super clear. Procedural programming is not bad. Not at all. It's actually incredibly straightforward, and it's perfect for small, simple tasks. If you just need a quick little script to organize some files or something, it's absolutely the perfect tool. But its big weakness has always been trying to manage those large, complex applications. OOP, on the other hand, absolutely shines when things get complex. It helps you write clean, reusable, and maintainable code, which is just essential for almost all modern software. So what's the catch? Well, the trade-off is that it does have a steeper learning curve right at the beginning, and sometimes there can be a tiny performance cost for all that extra organization. So look, if you remember just one thing, let it be this. Procedural programming is that single, detailed recipe. It's linear, it's direct, and it's perfect for one specific task. And well, that's the entire restaurant. It's a whole system of independent parts that all work together, and it can handle complex orders and scale up to serve a whole city.
Okay, so we've gone through the philosophies, we've seen the pros and cons. So the big question is, which one should you actually use?
Well, the most important takeaway here is that it's all about picking the right tool for the right job. For simple scripts or crunching some numbers or writing a quick algorithm, procedural is usually going to be faster and simpler. But if you're building large applications, video games, or the huge software frameworks that basically power our entire digital world, well, then the organization and scalability of OOP are pretty much non-negotiable.
For decades now, object-oriented programming has been the king. It's built the modern world that we live in today. But it's probably not the end of the story. New ideas are always popping up. So the question I want to leave you with is, what do you think comes next?